Hello, Mr. Biter here with the scientific method. When we're learning about the scientific method, we want to first be able to know the difference between an inference and an observation, know the difference between a quantitative and qualitative observation, and know the basic steps of the scientific method. What is the difference between an inference and an observation? Well, an observation is a statement of fact, but an inference makes a guess as to what happened. So an observation does not state an opinion. It is something that's actually seen. And an inference, however, makes a conclusion based on observations. Let's look at some examples. Make some observations about this picture. One observation might be that there is one truck. The truck is brown. You might also observe that there is something blue hanging from this tree. You could observe that it's cloudy. These are all great observations. Now, what would an inference be for this? An inference might be that this is after a hurricane. And an inference is based on observation. So I can observe that looks like there's been a lot of destruction. There's some water on the ground. There's some damage. But this could also be from a tornado. But I can infer or take a guess and draw a conclusion based on my observations. And scientists do this all the time. For this picture, you have one observation and one inference or one conclusion about what happened. Right, so you might have said an observation, well, the cat has some peg legs. You might conclude or infer that the cat tried to grab a hold of the piranha in the fish tank. That's a possibility. And scientists used these observations and making inferences all the time. No one's ever actually seen a dinosaur like this Tyrannosaurus rex. We can infer what it looks like, though. We can draw inferences based on the fossil record and how the bone structure is set up and how we can see that joints are attached together and muscles and ligaments are attached to bones. So we can find out a lot and infer what dinosaurs might have looked at by only looking at their fossils, though we've never actually seen or observed a dinosaur. Something similar happens when we think about Earth's interior. No one's actually seen the inside of the Earth, but we can infer what it looks like based on observations, data that we've collected as scientists. Right? We can know or take a guess as to what the interior of the Earth looks like, and that is just through observation. So observation is what we actually see, we observe it, we look at it, we can use our senses to find out information, whereas an inference is we're drawing a conclusion based on those observations. Now there's two kinds of observations. There's quantitative and qualitative observations. Quantitative observations involve numbers, like the length, volume, mass, temperature, all these quantifiable or quantities of things. That's a quantitative observation, whereas qualitative observations are descriptions. These are like color, texture, taste, things that we use our senses, and we can describe things. Those are qualities of something. That's a qualitative observation. And so when we make observations, we can ask questions. So we look at natural phenomena, we ask questions about it, and those questions are what we call the problem. The researcher has a problem that's being looked at, and that's the question that's being asked. And the hypothesis is a possible answer to that question. And many times scientists come up with multiple hypotheses, multiple possible ways to test that problem and see what the answer might be. But they have to be testable. They have to be something that's plausible and it could actually happen. After we have the hypothesis, we can make up an experiment, and then researchers will then look at the data that the experiment produces, that quantitative and qualitative data, those observations, and from that make a conclusion. And the conclusion will either support the hypothesis or it'll show that it's not correct. It'll refute the hypothesis. And scientists will then look at that conclusion and determine whether the experiment should be done again, should be done differently, or if they got to what they were looking for, and maybe they should make a new question based on what they found out. And science isn't so much about finding answers as it is finding good questions and asking more questions based on what you find out. And scientists will eventually publish what they find out and share it with other researchers and other scientists. So they have these journals that all scientists read in certain fields, and that research can be shared there and then repeated, because experiments, if they're good, should be repeatable. And that is the basics of the scientific method. Now, this is a scientific method I'm showing you. There are a lot of others. If you do a search for a scientific method, you look up images, you're going to find all different kinds of scientific methods. There is no one scientific method. A scientist isn't going to go out to do some research and she's not going to, oh, I'm going to go get the scientific method. No, it's intuitive. It's a problem-solving sequence. They know kind of what it is they're doing and the order that they want to look at and the logic they want to use. So the scientific method isn't one specific method. All right, it's a process. It's a way of finding things out about the natural world.